Hi, this is Professor McGivern talking to you about beer, the science behind fermentation. We're going to take a dive into a little bit of the science so that when we're looking at beer and we're thinking about beer, we have a little bit of an understanding of how it's made and the ingredients that go into it and how that process works. So that's kind of part of the reason, we're taking this is a CHM class and a writing class. So this is the CHM part of that experience. And one of the first things that we're going to get into and that you will see when we go to Germany, and we'll talk about the Reinheitsgebot, which is this idea that it's the beer purity law, and a law that was put into place back, I believe, in the 1600s. And that was put in there really it was one of the first food safety laws that was put into place. People were putting some weird things in beer, and the people were getting sick. And so a law was created so that only 3 ingredients could be put in there: barley, hops, and water. And later on, they figured out that yeast was actually part of that process as well, but not back in the 1600s. They did not know that existed. So it was those 3 things initially. And one of the kind of interesting things that you'll hear they'll talk about is the actual barley is one of those ingredients and not wheat. Wheat was purposefully not one of the things that were allowed in there because they didn't want the brewers and the people, the bakeries, the people that were making bread, to have to compete to use the same type of material. So that was not wheat. It's actually barley, which is a different type of grain. And so we will talk about what it is. Why do we need that? What does that do for beer? And why is that an ingredient that's used? So we'll talk about all of these ingredients as part of this discussion. And so let's go. The goal of the labs that we'll do during the class, during the semester, is to give you some ability, some hands-on experience of some of these different processes and points throughout the brewing process. Now, when we go to Germany, we go to these bigger, huge places where they're brewing thousands of gallons of beer, the equipment's going to look a little different. But the processes that are happening in our small scale setup are really very much similar, and we'll talk about some of those differences when we get to that brewery or while we're doing those processes. But I'd like you to do some of these hands-on experiences and do some of these steps. So we'll talk about those in the lab when we get to them. But I'd really like to start off with an explanation of some of the things that go into our beer and some of the ingredients, and more at a chemistry kind of level. So I don't want you to freak out or anything, but yes, here's the periodic table of elements. So these are all of the elements of the periodic table. You can see there are about 120 of these, a lot of elements. Now, fortunately for you in this class, we don't need all these elements. All of these elements are probably not in our beers, or if they are there, we don't necessarily need them or want them in there. So what we actually are going to do, I'm going to simplify this a little bit. I'm going to erase all of the ones that we for sure won't need. We go from 120 to more like 11. So that's probably a little bit easier, these 11 elements. And that's going to make up probably 99% of the elements that we're going to worry about in our beer. I don't want you to freak out, but I do want you to know a little bit about what's happening here. What is the difference between a carbon, nitrogen, and oxygen? And one of the big things here are all of these elements are made up of subatomic particles, protons, neutrons, electrons. And the big thing that I want you to know between a carbon and a nitrogen, for example, they all have different number of protons, so these P's. They're positively charged subatomic elements, and they attract these electrons. So if I have 6 protons in a nucleus, it's a carbon. If I were to add another proton, it would be a nitrogen. If I had an 8th one, it would be oxygen. So that's where these go, and then the electrons kind of float around on the outside. Now, this is a bit simplified, but that's essentially how we're going to look at it, at least for this class. So phosphorus has 15 protons, sulfur has 16, chlorine has 17. So we keep just adding those into this middle that we call the nucleus, and that defines what type of element we're talking about. Another science thing that we're going to talk about when we're talking about water, right? That one of those elements of the Reinheitsgebot. We really have to look at we do things in water because water is a good solution, a solvent for compounds in solution. So we can add different types of salts or ions, and that's when we have, for example, chlorine would have 17 protons. But if it had 17 plus 1 electrons, right, it would get an extra negative electron charge, and it would gain, it would be a full, it's basically this element has an extra electron in it. That's why we have that negative sign on the upper right hand side. Sodium over here, if we have normally 11 protons and it's got a plus charge, that means it actually had 11 electrons and it lost one. So now it only has 10. So it has a full positive charge. And so these things are generally drawn as little spheres here. And when we have things like a metal, so we have potassium, calcium, magnesium, sodium, those are actually all metals. And then lead and copper and all of those are over here, but we're not going to worry about those. I deleted them. But those could also be, those are ions. So whenever we have metals and non-metals combining, so that's over here in the yellow would be non-metal and a metal, then we form something called an ionic bond. So we just have charged elements coming together, and those, like chlorine here, is a non-metal, and then the sodium is a metal. So these would be ionic bonds. So when we have something from on the left side to the right side, those are ions, which means that they're not really sharing those electrons. They're kind of separate, but they're kind of like little magnets. They're charged elements. Now, when we go to covalent bonds, that's when we're taking the nonmetals binding to nonmetals. So all of these in the yellow. I know hydrogen's over here, but we also sometimes consider it as a nonmetal. So anything in yellow, if we're combining them together, so a hydrogen and a hydrogen, or a hydrogen and a carbon, hydrogen, nitrogen, oxygen, any of those, what they're actually doing, instead of swapping electrons like we did in the ionic state, they're actually going to share them. So they're going to take, like a proton has one, hydrogen has one proton and one electron, and we're going to pretend that little dot's an electron. We can actually share them like we are showing here, or putting a bond between them. They're actually sharing those electrons, and that's what covalent means. It means that they're sharing those electrons with each other. So going back to the periodic table that I simplified for you, really focusing on some of these, and I moved this hydrogen over to this other side here with the other nonmetals, and really focusing on really these four. So the other ones that are involved in ionic compounds, certainly they can be involved in some of the properties of the water in terms of how hard that water is, or how it, some of the beer, how it foams. But those are pretty detail-oriented things that we right now we don't need to get into. So really just focusing on these four elements: hydrogen, carbon, nitrogen, oxygen, and we throw a handful of phosphorus and sulfur sometimes in there. But 90% or more of life, what we consider as a living thing, will be mostly containing hydrogen, carbon, nitrogen, and oxygen. These four elements make up a vast majority of what we consider life. Something to note about this and where they are put on this little table here. Typically, hydrogen will, when we're talking about, I mentioned in a couple slides ago that we have covalent bonds, where these elements will share electrons with each other, and hydrogen will typically make one bond, oxygen will 2, nitrogen 3, and carbon 4. So we have these different things making different types of bonds, number of bonds. You can sometimes put the hydrogen over here, so that makes more sense in terms of the bond number, 1, 2, 3, 4. So hydrogen is an interesting element. There's a lot of different, it's unique in so many ways, and that's why can move it all over on the periodic table. So a couple of things that I'm just showing you down here. This is the kind of a basic structure of an amino acid, in terms of it's a part of a protein, one little piece or component of a protein. And you'll notice that nitrogen, hydrogen, carbon, oxygen, all of these elements are part of that. We're looking at beer making. One of the byproducts of that process is the generation of ethyl alcohol or ethanol. It's the same exact thing. The two different names for the same compound: carbon, oxygen, and hydrogen. So no nitrogen in here. We're just carbon, hydrogen, and oxygen. So these are some of the major components of the things that we'll be talking about in the first few sessions here. If you've ever taken some time to look at a food container, the nutritional facts on a package of chips or soda or any type of food that you have or buy in the grocery store, they always have these nutrition facts on here. And you'll notice that some of the things that they always have on there, they have to be on there, are the fats, the carbohydrates, and the proteins. And those are the three major groupings of what things that we can get energy out of, the food that we eat. There's also iron and potassium and vitamins in here. They don't necessarily do anything for us in terms of how much energy we get out of them, but they're needed for other processes. But these are the big three: fat, carbs, and protein. And this is what they look like on a chemical level. And here we just see all of the little bonds between, they're sharing electrons here between carbon sharing electrons, and this carbon has actually 2 bonds to this oxygen. So these are the chemical structure of, this is fat, for example, where we have big long chains of these carbons in a row. So that's kind of what a fat, an example of a type of fat molecule that would make up this type of compound. This is what it looks like. It's carbons, hydrogens, and oxygen. When we're looking at carbohydrates, they more look like this. They're typically ring structures. A lot of oxygen in these components as well, in these ring structures. So this is glucose, fructose, sucrose. You can see that they look similar, but there are little differences, right? This is a 6-membered ring versus 5-membered ring. Sucrose is a combination of glucose and fructose. So there are different flavors or different kinds of carbohydrates, but there are some that we can eat and generate and get energy from. So here are an example of those. We also have proteins, and I showed you before that amino acid. This is kind of one grouping, one component. These are all simplified amino acids. This is the amino acid glycine, for example. You have nitrogen, carbon, nitrogen, carbon. That's the backbone. And then you have the oxygen coming off that at regular intervals. So there are these little groupings of these amino acids make up long proteins. So those are examples of what we are going to be looking at. So these are where all of the carbons and hydrogens and nitrogens are drawn out. And this is a simplified version of that, where we basically, if you look at the fats, for example, each of these little corners represents a carbon and the hydrogens that are attached. And it's a shorthand way of writing this out. You can see how this can get complicated and the kind of things are running over each other. It's kind of hard to see that shape, but if we go here, it's very simplified, and every corner is another carbon. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons on this long fatty acid chain, and that's the same as this compound here, but it's just simplified. The same for the sugars. I actually took off some of the hydrogens that I should have drawn back on here, but we have these groups. We'll just simplify them and make them rings, for example. And then this is a simplified version of an amino acid. So these are different ways, shorthand ways that we can simplify those structures just to kind of show, okay, whenever you see a corner, that means there are carbons here and here. We're just not showing them just to simplify it, so you can kind of get the main gist of the organization of those elements. So at this point, you should have a journal, a notebook that you're using just for this class. And it should be bound on the edges, and then you'll use this for lab and for some of the class writing activities. So I'd like you to pull that notebook out, put today's date on it, and I want you to answer this question. And I'll bring it up in the lab at some point. But what are the atoms are present in here, and how many of each? So you'll see there's this little code down here for what those elements are. I'd like you to go back to that slide or pull out a periodic table from the internet and I want you to identify which atoms you see here based on this code representation. So how many are there? Make a little chart. So what different types of elements can you see on here? How many different versions are there? And then how many? So count all of the different types that you see. So if you see a phosphorus, how many times do you see it? Write that down in a little sheet, and then we'll come back to this. But I just want to be able to make sure that you can recognize what this is and what this looks like if you see something like this, just to be able to decode it, if you will. So one of the big things that we need to kind of understand about this whole situation, about what's happening and why we can make ethanol out of beer, is that we start with really big things, and we're going to break them down. We have yeast that's going to eat this stuff, and then it's going to turn them into smaller things, and we get energy out of that. So that's where that happens. We're making, I'm showing you here some components of carbon dioxide and water and urea, and those things are released when we are eating something. But we're also going to talk about the building up, the anabolism of the different compounds. So basically we have plants like the barley is going to take up some of these compounds. They're going to get energy from the sun, and they use that energy to build bigger things. And that is what we see up here, larger components, larger chemicals. And then we can eat them and break them down, or yeast can eat them and break them down. So that's how that process works. That's why this happens, is we get the food source, right? The plants are taking this small stuff from the environment and building it into big stuff. And that's why we eat plants. And that's why animals eat plants, because they have stuff in them that's built up. The energy from the sun, they're using that. And typically the plants want to use that for themselves, to put that energy into their seeds, so then they can spread their other plants to other part of the environment. But we also then will steal those seeds and eat them and get energy out of it. So that's kind of how we work, and that's why that system works. So typically we'll eat these things on the top, proteins, fats, sugars, and then we release these other elements, carbon dioxide and water, and then urea and water. That's basically what we pee out. So that at least gets us started in terms of the starting point for making beer, at least understanding some of those, the chemical symbols, what they mean. And then we'll start to use those more and build on that idea to then start looking at some of the things. For example, we'll start with looking at just generally some nutritional information in terms of food that we eat and how that works. And then we'll get into what's happening with that barley. So that's the end of this first quick little video regarding the science of beer.